This is the setup for the refraction lab. The materials we used were a ray box, a half-circle prism, and a sheet of paper. The purpose of this lab was to find the refractive index of perspex. The refractive index is the ratio of the speed of light in a vacuum to the speed of light through the material. The ratio determines how much light rays are bent. The greater the bending power, the greater the refractive index. After setting up the lab, we had to trace the shape of the half-circle prism onto the paper. We then began the experiment by shining the light of the ray box onto the prism, thus creating a reflective line of light. In this experiment, there were 10 trials. In each of these trials, the aim was to get a different angle of incidence and therefore of refraction. As we were conducting this experiment, we were recording the data onto Microsoft Excel so we could see the relationship between the angle of incidence and the angle of refraction on the graph. We continued shining the ray box and creating angles, which we then marked onto the diagram and measured with a protractor. We had to measure the different angles of incidence and angles of refraction in order to obtain data for our graph. The angle between the light ray and the normal as it leaves a medium is called the angle of incidence. The angle between the light ray and the normal as it enters a medium is called the angle of refraction. There were many factors to discuss during this experiment. We had to measure all of the angles and record them into a table. The greater the bending power of the angles, the greater refractive index. When you shine light through a transparent medium, in this case the perspex prism, the ray bends. However, when you shine a ray without any obstruction, then the ray continues in the direction it is shown. This is the finished result with the different angles of incidence and refraction. We can see that the angle of refraction is always greater than the angle of incidence. The slope of the graph gives you the refractive index of perspex. The slope is the ratio of sine r and sine I. The equation for the refractive index is y equals 1.482x plus 0.08. The actual refractive index is 1.495. The percentage error we got was negative 0.87%. Even though this was an extremely small percentage error, we could have gone wrong in the measuring of our rays, the marking, or our rounding.